On the other video, we did questions 1 and 2. Now I'm going to do 3. And step 1 is to find the vertex. Don't be lazy, guys. Write down the word vertex. Write down the coordinate right below it. Write down the formula x equals negative b over 2 times a. Rewrite that formula x equals, but instead of the b, put parentheses, and instead of the a, put parentheses. And then go to your quadratic equation and identify your a value of 1, your b value of negative 4, your c value, which is 0. You don't even use c. So keep in mind, guys, a standard form quadratic trinomial is always ax squared plus bx plus c. The c value has no variable. Now, on number 2 above, or on number 1 above, there was no b value because there is no x term. But on the one we're on now, there's no c value, there is a b value. As you can see right there, the b value is negative 4, the c value is not there. So let's use those a, b, and c values, or just the a and the b value, to find the vertex. The b value is what? What's the b value?
0.
Negative 4.
Oh.
The a value is what?
1.
Let's work this out, guys. X equals positive 4 divided by 2. So x equals what? 2. Thank you. We have the 2 of the vertex. Let's find, we have the x of the vertex, which is 2. Let's find the y. How do we find the y? Plug it in. So let me rewrite my original equation. But instead of the x's, as you could see, I put parentheses. And now I'm going to plug in the x value of 2 right in there and there. So I'm going to plug in my x value of 2 right in there. And let's do PEMDAS. Parentheses, there's nothing to do. Inside the parentheses, we move on to e exponents. 2 squared is what? 4. Let's rewrite the rest. We have a negative 4 times 2. After exponents, we do multiplication. 4 times 2 is what? 8, negative 8. So we really have 4 minus 8. And what is 4 minus 8? Negative 4. So the vertex y value is negative 4. I found the most important point. Let's graph the most important point. 2, negative 4. Okay? So let's go 2 on the x, negative 4 on the y, and we end up right here. Everybody with me? Right after the vertex, what's the very next thing we need to do on this graph? Axis of symmetry. That's what provides the reflection. Now, after you draw the axis of symmetry, you need more points so you could actually reflect. So you could either go to an XY table, or you could use the pattern. Whenever your a value is 1, you could use the pattern. Pattern is 1, 1, 2, 4, 3, 9 from the vertex. Let me repeat that, from the vertex. So if you go to the vertex and you go 1 over, 1 up, you're going to get a dot right there. And then the next one would be go 2 over and 4 up from the vertex. So go 2 over and 1, 2, 3, 4 up and put a dot right there. And the last one is 3 over 9 up. So from here, 3 over 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9 way up here. And of course, we map them over to the other side using that axis of symmetry. 1 unit away, 2 units, 3 units. So let me map that over. There's one, there's another, and there's the last one. So let's draw it. And we have our perfect parabola, my regular U-shaped curve. Arrows are on it because it continues forever. Now, this is just an option. It's a shortcut. The pattern 1, 1, 2, 4, 3, 9. Once again, the a value tells you how wide it is or how narrow it is. The a value of 1 will always have this regular pattern of 1, 1, 2, 4, 3, 9. So it doesn't matter if you had a different c value, or if your b value was different, or even if the a value was negative 1, you could use the pattern 1, 1, 2, 4, 3, 9 after finding the vertex. Now let's say you didn't want to memorize that pattern, which I think is silly. I mean, memorize it, it's the easiest thing to do. But if you don't want to memorize it, you could go back to your XY table and plug in some easy points that are on the same side of that green line, the axis of symmetry. So what would the easiest point to plug in be? If you plug in 0, let's pretend that we didn't have it graphed. If you plugged in 0 up here, what's 0 squared? And what's 4 times 0? And 0 minus 0? So for the input 0, I get an output of 0. And notice I already have that point. With the pattern, I already had that point. Let's plug in another number. What other number would you like to plug in? 1. Okay, if we plug in a 1, what's 1 squared? What's 4 times 1? 4. So what's 1 minus 4? Negative 3. So when I plug in 1, I get out a negative 3. Now, where's the coordinate 1, negative 3? Let's go 1, negative 3. Oh, it's that point right there. You see how it's kind of like a waste of time to do all this math? If you just already know that the a value is 1, you could use a pattern 1 over 1 up, 2 over 4 up, 3 over 9 up. And it's always from the vertex. So this pattern is amazing because all you're doing is finding the vertex, and after that you double check and make sure you understand if it's opening up or down depending on the a value, if it's positive or negative, and then knowing that it opens up or down, you're going to use the pattern 1, 1, 2, 4, 3, 9. I mean, we could continue to plug in numbers. Like let's say I plugged in the number 5 and I did the math. 5 squared is 25. 4 times 5 is 20. 25 minus 20 is 5. So when I plug in a 5, I get out a 5. And if I went to that coordinate 5, 5, I get to that point anyway. But you see how I got all those points with the simple pattern of 1, 1, 2, 4, 3, 9? This pattern is available on any parabola that has the a value of 1. Okay? All you got to do is know if it's opening up or down depending on if the a value is positive or negative. I have not shown you how to use it if the a value is 2 or 3. Maybe later on I'll show you how to force it. But right now, number 4, could we use the pattern on number 4? Yeah. Absolutely. But we still need to go through the steps. And you don't have to use the pattern. You could always go back to the XY table. So step 1, what is it? Vertex. And not step 2, but let's actually, how do we find the vertex? Formula. How do we use the formula? You plug in, but with parentheses. All right, very important that you use parentheses. So once you rewrite it with parentheses instead of the variables, go identify that the a value is what? What's the a value? Negative 1. The b value? Negative 6. The c value, which we don't even use, is negative 8. Now, why am I keeping on repeating what's the c value? Because on the next section, we're going to be doing the quadratic formula, and you need to know a, b, and c. Okay. Anyway, right here, let's plug in what we know. The b value is negative 6. The a value is negative 1. And when we work this out, we're going to get x equals positive 6 over negative 2. And what is positive 6 divided by negative 2? Negative 3. That is the x value of our vertex. How do I find the y value? You plug in the negative 3 into your x values. Now again, whenever you plug in, please rewrite it with parentheses before plugging in. So there's my entire equation rewritten, but instead of the x's, I put parentheses. Now I could safely put in that negative 3 value into those parentheses. And now we could do the math. Now, please do not make the mistake of changing these minus to plus. That would be incorrect. The reason why we change a minus to a plus is because of multiplication. A negative times a negative equals a positive, right? But what must we do before multiplication according to PEMDAS? Exponents. So you have to start with the exponent, negative 3 squared. And what is negative 3 squared? Positive 9. So you get a positive 9, you bring down the negative that's in front. Let me bring down everything else so we don't get confused. And then I do the math. After exponents is multiplication. So I could think of that as a negative 6 times a negative 3, that's positive 18. Bring down the minus 8, bring down the minus 9. And from left to right, we're going to do the math. Negative 9 plus 18 is 9, and 9 minus 8 is 1. So our vertex y value is 1. That's the most important point on any parabola. So let's graph that most important point. Negative 3 on the x, positive 1 on the y, and you put it right there. That's a vertex, negative 3, positive 1. Now, after you draw the vertex, you have to instantly draw the axis of symmetry. Okay? Axis of symmetry is that vertical line that crosses right through the vertex. Now, if you wanted to give an equation, because some tests or quizzes, they will ask you for the equation of the axis of symmetry. If you wanted to write the equation of the axis of symmetry, any vertical line is written x equals, and it's just the x value that it actually crosses through. So the equation of this axis of symmetry is x equals -3. Okay? So if a certain homework or a certain quiz or test says, write down the equation of the axis of symmetry, all you do is write down x equals whatever the x value of your vertex is, which in this case is -3. That'll be the vertical line. X equals -3 will produce that vertical line. Anyways, let's go back to actually graphing this parabola. We definitely need more coordinates. How do we find more coordinates? You could go for an XY table, but if you're comfortable with the pattern 1, 1, 2, 4, 3, 9, let me write that down, 1, 1, 2, 4, 3, 9, then that would be the smart way to approach this. Now, you could only use the pattern 1, 1, 2, 4, 3, 9 because your A value is -1. Doesn't matter if it's positive or negative, as long as it's 1, then you know you could use the pattern 1, 1, 2, 4, 3, 9. Now, the pattern is from the vertex always. You have to go back to the vertex and you do the pattern, go back to the vertex, do the pattern. Now, and you also need to understand if this parabola is opening up or down. So tell me, is it opening up or down? Down, because it's negative. So I'm going to be at the vertex, I'm going to go 1, 1. 1 over, 1 down. And you put a dot right there. And then we go back to the vertex, and we're going to do the next one, 2, 4. So from the vertex, 2 over, 1, 2, 3, 4 down, and put a dot right there. And of course, because this is a tiny graph, if I went 3 over and 9 down, I'm going to be way off the graph, so I'm not even going to graph it. Okay? But the axis of symmetry is great because it provides a reflection. So just go ahead and reflect those dots onto the other side of the axis of symmetry. As you can see right here, it's 1 unit away, 1 unit away, 2 units away, 2 units away. And now we could actually draw our perfect parabola opening down. And that's how you graph it. You don't have to use a pattern. You could have used the XY table. Like you could have plugged in numbers that are on the same side of the axis of symmetry. So if you did plug in 0 for x, you get out a -8. That's off the graph. That wouldn't be that great. So you'd probably plug in a -1. And if you do all that math by plugging in -1 correctly, you will get out a -3. So it's a lot faster to understand the pattern 1, 1, 2, 4, 3, 9. Now, there's a couple of other things we could state about this parabola that we just graphed. Does it have a max value or a min value? Max value, absolutely, right? It's kind of like the path of a ball. You throw it up in the air, reaches a max height, then it comes back down. So it does have a max value. And the understanding of that will help you out in determining the range in a little bit. So what else are we going to state? We're going to state the domain. The domain are your x values. And the truth is, the domain of any parabola, whether it opens up or down, whether it's wide or narrow, let me repeat that. The domain of any parabola is x equals all real numbers. Okay? Keep that in your memory. The domain of any parabola is x equals all real numbers. That makes total sense because x is really the inputs. I mean, so what numbers could you plug in? If you were to make an XY table, could you plug in 0? Yeah. Could you plug in 1? Yeah. Could you plug in 1,000? Yes. Could you plug in a fraction like 1/2? Yeah. You could plug in a decimal. You could plug in anything you want into these x's, and you'll be able to work out the math and get a y value. So the domain values, the x values, is any number you want, all real numbers. Visually, it goes that way forever. Even though it goes down, it continues to travel to the right forever. And even though it goes down, it continues to travel to the left forever. So the domain really is x equals all real numbers. The range, that's the interesting one because that's the y value one. And the y's either go up or down. So this entire parabola, where is it at in terms of y? Let me ask you this. Does the parabola exist at the y value of 3? No. Does the parabola exist at the y value of 3? Is it up here at this level? No, it's not. Does it exist at the y value of 5? No. Does it exist at the y value of -5? Yes, because it'll eventually get there. Does it exist at -3? Yes. Exists at -1? Yes. So if you want to describe where this parabola exists in terms of the y values, obviously this is the highest point, the max value, and the entire parabola is below this value of 1. So what do we say for the range? We say y is less than or equal to that y value of 1. Y is less than or equal to 1. I think we forgot to state the domain and range of the previous one. Let's go back up. So what's the domain on this top one? X equals all real numbers. Doesn't matter what kind of parabola it is, the domain is always x equals all real numbers. Now the range, let me just put an imaginary line right here. Don't draw it. It's just so you guys could see. This whole parabola is above this blue line, right? And this blue line really is y equals -4. So what could he tell me? This whole parabola has a y values that are greater than or equal to -4. It's all above or at that minimum value of -4. Does that make sense? So the domain should always be easy, x equals all real numbers. The range, that's where you determine, oh, it's all above the y value of 4, so y is greater than or equal to. Why is it or equal to? Because it actually touches the y value of -4. The minimum value is right there. So the range is just, where's your parabola at? Right here, the whole parabola is below, at or below the y value of 1. So the range is y is less than or equal to 1. So I explained two questions on the previous video. I explained 2 questions on this one. Now up here, number 5, we cannot use the pattern 1, 1, 2, 4, 3, 9. I mean, we could, but I don't want to show you how to do that yet. Right now, I'm going to pause it, or I'm going to end this video, and we'll pick it up on the next one here.